Hello, today I will start a small video cycle dedicated to programming on microcontrollers. I will make a video soon in the format how-to or quick implementation of some features. And I decided to start with such a topic as the implementation of USB-MIDI converter using an STM32 microcontroller or some other. Because there is no matter what the MCU we will use, but note that the MCU should support the USB functionality. In my current case, I will use the STM32 Nucleo F411 board. You can see this on my table. Also, now there are many different alternative solutions, in particular on other processors from manufacturers like Giga Devices or Artery. For example, I have the Artery dev board that looks the same functionality as STM32 and also this has some analog of ST-Link programmer. You can see this. The original ST-Link looks like this. And let's continue. I will show you how implement the USB MIDI converter functionality, and I will split my sprint for this task at two videos. At first, I will configure the project in CubeMX, and at the next time I will show you how to implement and change the code specifically for USB MIDI converter functionality. Let's look at our development board. For USB MIDI converter we need a USB port. The USB functionality is implemented in this MCU, but this board doesn't have the external USB port separated socket. Due to this, I will use the external USB socket, which looks such. I have two of them, but only one, so only this one has the mounted resistors for USB full speed configuration. As you know, each type of USB port according to the speed has own configuration in pull up or pull down resistors. For USB full speed, the positive data wire should be pulled up to positive voltage. Okay, let's start the project with MX Cube. Let's start the new CubeMX project. At first, we should select our MCU model. This is STM32 F411 RET. Then let's go to System Core tab and at first select the debug as serial wire. Then we should to switch on the external crystal oscillation. So I use the external crystal at 8 MHz, but note that by default the Nucleo board usually doesn't have the external crystal oscillator. So let's select in high-speed clock crystal ceramic resonator. Then go to connectivity, USB OTG-FS, and select device only. Then go to middleware and select the type of USB class. We should select our device class. Okay. Briefly, that is all, and also I want to switch on some LEDs for controlling my MIDI interface. I will configure some pins as output. I will configure PC2, PC3 and PB3 STM32BB4. Okay. Then let's go to clock configuration tab, and in this tab we will configure our clock sources. As I mentioned above, my crystal oscillator has 8 MHz external clock. So select HCA source, divide by 0, select parallel silica source, and change the PB per scalar to 2. And that is all. Go to project manager tab and enter our project name. I will name this as USB-MIDI converter. Oh, sorry. And also we should select the current toolchain or IDE. In my case, I will use the STM32 Cube IDE. Also, let's configure minimum heap size to this value and stack size also. Okay, and now we can generate our code. Press the generate code button, open project, yeah, we'll see the project opened in Cube IDE, and that is all. And at the next video I will show you how you need to modify the code to implement the USB MIDI functionality, and also at the next video we will try to flash our board. Thanks for watching, goodbye.